Good morning everyone, my name is Charujan and today we are going to discuss numerical based on dependent source. Okay, in this we need to calculate according to the Thevenin equivalent. We need to calculate VTH and RTH. So how can we do? We have to follow certain steps of KVL, then accordingly we can do it easily. Okay, step number 1 is mark current direction. You need to mark current direction. If you have not seen my previous video of KVL, then you can see this. Okay, now first step is to mark the current direction. In this, first of all we should see that how many meshes are there. In this, suppose, just imagine this is your house. Okay, and in this house how many rooms are there? As you can see that there are 2 rooms, right? You can see that there are 2 rooms only. This is the open circuit, so this is not a room. So 2 rooms means how many meshes? 2 meshes, and 2 meshes means you need to take how many variable? 2 variable. So you can write down 2 mesh, 2 variable. Okay, now in this you can see that from V1 to V0 they have given Ix is the current flowing. So we can also mark from V1 to V0 Ix is the amount of current flowing. Okay, I have taken the same so that one variable can be neglected. In this they have given V1 to V0 Ix is the current flowing, and we have also taken V1 to V0 Ix is the current flowing. I have taken the same direction. Do notice this point. Again in this also I have taken the another current, that is I1, that is flowing in the clockwise direction. You can take it clockwise as well as anti-clockwise, that depends on you. Now our step number 1 is completed. Move to step number 2. Step number 2 is mark sign convention. You need to mark sign convention. As you know that current always flows from higher potential to lower potential, right? Current always flows from higher potential to lower potential. So if current flows from A to B, then you will mark positive here and negative here. So accordingly I am marking the direction of I am marking the sign convention. You can see this Ix is flowing from this direction, so you will mark positive here, negative here, positive here, negative here. In this I1 is the current flowing like this, so positive here, negative here. Battery sign will remain positive and negative. Now our step number 2 completed. Move to step number 3. We need to apply KVL, that is Kirchhoff voltage law. So for this you need to calculate what? VTH, right? VTH must be equal to VAB, because we need to calculate Thevenin voltage across A and B terminal always. So this one is terminal A and this one is terminal B. Okay, so we need to calculate VAB, that is equivalent to VTH. Now our focus is to calculate VAB. How can we calculate VAB? Just you can see that from A to B there is no direct connection, right? So you are standing at the A position and you need to move it across B, right? Just imagine that you are standing at A, this is your home suppose, and you need to go it to B. Okay, so we need to calculate VAB. How can we calculate VAB? You are standing at A position, the voltage across A would be VA. Okay, now you need to take second sign, whatever second sign which is coming in your path, you have to take that. If you are moving from A, then what is the second sign which is coming in your path? That is positive. So plus, resistance is how much? 6, and current is how much? Ix, right? You are moving from V1 to suppose this C. What is the second sign which is coming in your path? That is plus, resistance is how much? 10, current is how much? I1. You are moving from C to D. How much is the second sign? Minus, voltage is how much? 12. Okay, D2, then nothing is there, then back to B, that is potential at B point is VP is equal to 0. So this is your equation 1. Clear this equation? Just imagine that you are standing at the A position and you need to move it across B. So you are at A position, that at that point potential will be higher, that's why I have taken VA. At B position potential is lower, that's why I have taken VB. Okay, so VA minus VB, we can write down VAB plus 6ix plus 10i1 minus 12 is equal to 0. Okay, so in this basically dependent source question we have to take loops. This we have taken KVL in outer loop. This is the outer loop we have taken, and we apply KVL in the outer loop. From this we will get this equation. Now we need to take KVL in inner loop. Okay, KVL in inner loop. So see how which loop we can take inner loop, that is V0 to C, C to D, then D to E. I am marking this point also. F C D E, F C D E. This is the inner loop. Again you are moving from F to V1, second sign plus 6ix, right? Then again V1 to C plus 10i1, then minus 12, okay, then plus 8ix is equal to 0. So this is your equation second. Okay, this is your equation second you got. Clear up to here? You can solve this equation, and then for now you can see that how many variables are there in this. How many variables are there? VAB is one of the variable, ix is one of the variable, and i1 is another variable. Similarly in this also ix is one of the variable, i1 is one of the variable. So in this how many variables are there? 3 variables are there, and for solving 3 variables we need at least 3 equation. But how many equation we got? 2 equations. So we need to calculate another third equation so that we can solve it further. Okay, and how can we got third equation? From this dependent source. You can see this is a dependent source, and which source it is? It is a current dependent current source, CDCS. Why it is a current source? Because in this arrow is given, as you know that if arrow is given, that source is current source, and it depends on the value of current, right? It depends on the value of current. It depends on ix. It is depending on ix. So it is current dependent. That's why it is called as current dependent current source. Current source, why? Because it is in arrow. Okay, and ix is, its value is related to the ix. That's why it depends on current. So it will behave like a current source only, normal current source only. So in this you can see that if your current is moving from G to V1, right? The current they have given, that is moving from G to V1. How much they have current moving from G to V1? That is 1.5 ix, right? And you have imagined that I1 is the current flowing from V1 to G, right? V1 to G, how much is the current flowing? That is I1, right? Similarly ix is the amount of current flowing from G to V1. G to V1, how much current is flowing? Ix. So basically in this middle branch, this is a basically middle branch, in this how many currents are flowing? Basically 3 currents are flowing. If we will see from your room, suppose as I told you, this is your room, you are moving from V1 to G. In your room you are moving from V1 to G, you are I1, and this is your friend's room. Okay, your friend is moving from G to V1, your friend is moving from G to V1. Obviously it's your choice now that how you are moving. You can move from up to down, and you can move from down to up. It's your choice. Okay, so they are moving like that. But what they had said in the question, that normally current flows from down to up, as they have shown by the arrow. So normally their current is flowing from G to V1. Okay, so if the currents are flowing in the same direction, then you will mark positive. If the currents are flowing in the opposite direction, then you will mark negative. It is a golden rule. You can write down, if the currents are flowing in same direction, then positive. If the currents are moving in opposite direction, then negative. Okay, I hope up to here it would be clear to you. So accordingly, what we can write down the third equation, we can write down the third equation is G to V1 Ix is positive because it is moving along the direction, and V1 to G means I1 is moving opposite, so it would be minus I1 is equal to 1.5 Ix. So this is your third equation you got. Okay, I'm repeating this. You can see again from this that your current is moving, like just imagine you are I1. Okay, you are I1, you are moving from up to down, which is exactly opposite from the current source. So that's why you are negative, and your friend is following the same path. Your friend is moving from up down to up, that is exactly the same which is moving across the current source. That's why your friend is positive. Okay, so if you are moving across the same path, then it would be positive, and if your friend is moving across the different path, then your friend will be negative. Okay, I hope it would be clear to you. This is basically a normal current source technique. So in this, how many equation we got? That is 3 equation. 3 equation means 3 variable, and you can solve it. By solving it, you will get the value of VAB, and what we will get, that is 10.66 volt. I hope this you can solve it with the help of calculator. Okay, you can see my video of calculator also, that how to use scientific calculator for solving variables. Clear? Okay, next step is to calculate RTH. Okay. How can we calculate RTH? For solving RTH, we need to apply a test source. Okay, how can we apply test source? Just see, this we have calculated voltage, but now we need to calculate RTH. So for calculation of RTH, we need to follow steps. Again, step number 1, we need to apply test source. Okay, what is that test source? Test source can be voltage source of 1 volt, and test source can be current source of 1 ampere. Okay, so you need to apply test source where? Across AB terminals. Always apply test source across AB terminal. So in this, I am applying test source as a current source. You can apply any source, I am again telling you, but I am here applying current source. Okay, current source of how much? 1 ampere. Okay, instead of current source, you can also apply voltage source, that depends on you. So 1 ampere is the amount of current which I have applied. Next is step number 2, that short circuit voltage source, if there is any voltage source present in the circuit, or open circuit current source. Okay, if there is any current source, but we don't need to touch any dependent source. Don't touch dependent source. Okay, so in this case, is there any voltage source? Yes, this is the voltage source. We need to short circuit. Short circuit means we just need to close. Okay, remove that source. Okay, and we just need to place a wire across this. I hope you know what is short circuit and close circuit. Short circuit is simply closing the door. Open circuit is simply opening the door. Just you can remember it like that also. Short circuit is closing the door. Okay, so I have closed this door. Now, what is the value of voltage here? That is V0. Okay, as you know that in a plain wire, at every point voltage is same. Suppose here voltage is V0, here also V0, here also V0, until and unless any element is connected between these wires. So if there is a plain wire, at every point potential is same. So if here it is V0, then here it is also V0. Clear? I hope it must be clear to you. Now our focus is to calculate RTH, right? What we need to calculate? RTH. And according to Ohm's law, you know that V is equal to I multiplied by R. So R must be equal to V divided by I. So RTH must be equal to V naught divided by I naught, right? So RTH is equal to V naught. How much? We don't know. We need to calculate. But I naught is how much? 1 ampere. So I naught is basically the current source which we have applied. Okay, and it is I naught. Now our focus is to calculate V naught. If we'll get the value of V naught, then we'll get the value of RTH also. Correct? Now how can we calculate V naught? We can apply KCL also. We can apply KVL also. But if I am applying here current source, then it's better to use KCL. If I would apply voltage source here, then it would be better to use KVL. That depends on you, whatever you want to apply. Okay, but in this I am applying KCL here. So how can you apply KCL? How many nodes are there? See, 2 nodes are there. 2 nodes means 2 variable. So V1 and V2 naught are the 2 nodes. So we need to mark the current. This one is suppose I1. This one they have already given, that is 1.5 Ix. This one also they have already given Ix. This one suppose we will mark I2. Okay, and this we know that how much current is flowing, 1 ampere. So apply KCL at node V1. What does KCL states? KCL states that sum of incoming current is equal to the sum of outgoing current. This is a node. How much current is entering in a node? Okay, just imagine that this is your house, okay, or this is your room. How many people are entering in your room? Okay, so how many people? 2. I1 and 1.5 Ix is entering, and how many people leaving your room? That is Ix. So sum of current which is entering, that is I1 plus 1.5 Ix is equal to how many people leaving your room? That is Ix. Okay, now we need to convert I1 in terms of V by R. This is a reference node. So you know that at reference potential is 0. So your current is flowing from 0 to V1, right? So it would be 0 minus V1 because your current is moving from 0 to V1 node. So it would be 0 minus V1 divided by resistance. How much resistance is there? 10 ohm. And if, okay, this 12 volt is nothing because we have short circuited. Now again, if current source is present, we don't need to convert it into voltage terms. Direct write down 1.5 Ix is equal to Ix. This is the equation 1 you got. Okay, similarly apply KCL at node V0. V0, how much current is entering in V0? That is Ix plus 1, right? Because from here this direction also 1 ampere is coming in your node. Again imagine that this is your room. How many people are entering in your room? Ix and 1, right? And how many people leaving your room? That is I2 according to this. Ix we can write down as it is Ix, 1 we can write down as it is 1, and I2 is how much? V2, V0 minus 0 divided by 8. Clear? Because this I2 current is flowing from V0 to ground, V0 to 0. So this is your equation 2nd. Now we need to see that how many variables are there. See, first variable is I1, another variable is Ix, and another variable is V0. So how many variables we got? 3 variables. 3 variables, we need 3 equation for solving. So we need to calculate third equation also. And how can we calculate third equation? From this dependent source equation. Like they have said na, that their current depends on current source. That's Ix is the current dependent. So this Ix is always present in somewhere else. Okay, this Ix is always present in somewhere else. So we can calculate it from here. So you know that I is equal to V by R. Ix is equal to, this Ix is current flowing from which node to which node? It is the current flowing from V1 to V node. We will always see that current is flowing from which node to which node, okay, like which room to which room. So this Ix is moving from V1 room to V node room, right? So your Ix is current moving from V1 to V node, so it would be V1 minus V node divided by resistance, that is 6. So you got this third equation, correct? Now you can solve this, all this equation. By solving, you will get the value of V naught. V naught, how much we got? That is 0.88 volt. You can solve it, this equation, by your own, right? This is just through calculator. So this is the value of V naught, or you can say this is the value of this V naught. Now our main focus is not to calculate V naught. What we want, we don't want V naught, we want RTH. So RTH is V naught by 1 ampere. So V naught is how much? 0.88 divided by 1 ampere. So you will get 0.88 ohm. Okay. Now we need to calculate Thevenin equivalent. You know that Thevenin equivalent is the VTH, which is connected in series with RTH, and these are the A and B terminals. VTH value we got how much? VTH value we got, that is 10.66 volt, and RTH value we got 0.88 ohm. So this is the solution. I hope it would be clear to you. Okay, if you have any doubts in this question, you can contact me. Okay, my contact number is 9034223003. Okay, thank you.